This video we will discuss about what is a public key cryptography. Public key cryptography, also known as asymmetric cryptography, is a framework that uses both a private and public key. As opposed to the single key used in symmetric cryptography, the use of key pairs gives PKC a unique set of characteristics and capabilities that can be utilized to solve challenges inherent in other cryptographic techniques. This form of cryptography has become an important element of modern computer security as well as critical component of the growing cryptocurrency ecosystem. How does public key cryptography work? In a PKC scheme, the public key is used by a sender to encrypt information while the private key is used by a recipient to decrypt it. Because the two keys are different from one another, the public key can be safely shared without compromising the security of the private one. Each asymmetric key pair is unique, ensuring that a message encrypted using a public key can only be read by the person who possesses the corresponding private key. Because asymmetric encryption algorithms generate key pairs that are mathematically linked, their key lengths are much longer than those used in symmetric cryptography. This longer length, typically between 1024 and 2048 bits, makes it extremely difficult to compute a private key from its public counterpart. One of the most common algorithms for asymmetric encryption is in use today is known as RSA. In the RSA scheme, keys are generated using a modulus that is arrived at by multiplying two numbers. In basic terms, the modulus generates two keys, public that can be shared and one private that should be kept in secret. The RSA algorithm was first described in 1977 by Rivest Shamer and Adleman and remains a major component of public key cryptography system. PKC as an encryption tool. Public key cryptography solves one of the long-standing problems of symmetric algorithms, which is the communication of the key that is used for both encryption and decryption. Sending this key over an insecure connection risks exposing it to the third parties, who can then read any message encrypted with the shared key. Although cryptographic techniques they are still vulnerable to attacks. In public key cryptography, by contrast, the key used for encryption can be shared securely over any connection. As a result, asymmetric algorithms offer a high level of protection when compared to the symmetric ones, generating digital signatures. Another application of asymmetric cryptography algorithm is that of authenticating data through the use of digital signatures. Basically speaking, a digital signature is a hash created using the data in a message. When that message is sent, the signature can be checked by the recipient using the sender's public key. This way, they can authenticate the source of message and ensure that it has not been tampered with. In some cases, digital signatures and encryptions are applied together, meaning the hash itself may be encrypted as a part of the message. It could be noted, however, that not all digital signature schemes use encryption techniques. Limitations. Although it can be used to enhance computer security and provide verification of message integrity, PKC does have some limitations owing to the complex mathematical operations involved in encryption and decryption. Asymmetric algorithms can be quite slow when forced to deal with large amount of data. This type of cryptography also depends heavily on assumptions that the private key will remain secret. If a private key is accidentally shared or exposed, the security of all messages that have been encrypted with its corresponding public key will be compromised. It is also possible for users to accidentally lose their private key, in which case it becomes impossible for them to access the encrypted data. Applications of public key cryptography. This type of cryptography is used by many modern computer systems to provide security for sensitive information. Emails, for example, can be encrypted using public key cryptography techniques to keep their contents confidential. The secure sockets layer protocols that make secure connections to websites possible also employs asymmetric cryptography. PKC systems have even been explored as a means of providing a secure electronic voting environment that would potentially allow voters to participate in elections from their home computers. PKC also features prominently in blockchain and cryptocurrency technology, when a new cryptocurrency wallet is set up, a pair of keys is generated. The wallet address is generated using the public key and can be securely shared with the others.